Hello, my name is Levermann. I'm a physics professor at the Potsdam Institute for Climate Impact Research in Germany and a scientist at Columbia University in New York. In Potsdam, I'm heading the Department of Complexity Science, which deals with all the cool stuff in climate research, all the way from the physics of weather extremes to their impacts in the global economic network. The climate challenge is, for better or for worse, the greatest story of our times. I look at it as a scientist, but I believe it has great potential for interactive storytelling. And even though it's a serious problem, I don't believe it belongs into the serious games category because it's way too threatening for that. I give talks to decision makers in business and policy. I've been consulted by film producers and the US Army Corps of Engineers. And I'm thrilled to give a talk to you today because I believe that the gaming industry has the strongest impact on today's popular culture and arguably today's culture altogether. Now, when I was 5 years old, a US glaciologist, John Mercer, published a paper in Nature, which is one of the highest science journals altogether. And he made a number of predictions in this paper, and I titled this slide, "In Physics We Trust," because the predictions turned out to be true. The first thing he said was that if we continue to emit carbon into the atmosphere in form of carbon dioxide, then we'll have doubled the amount of carbon dioxide in the atmosphere after a period of 50 years. Now, we're not quite there yet, but we're almost there. And that was a reasonable prediction. It wasn't really a physical one because it was just extrapolating a curve into the future. So the real physics was in the other statements that he made. And one of them was that the consecutive warming that it will be caused by the CO2 in the atmosphere will lead to a disintegration of the ice shelves on Antarctica. And in the year 2002, it was the last B-ice shelf that you see here that was the first one to make it to the front page of the New York Times because it disintegrated over a period of 10 to 14 days. But that wasn't all of John Mercer's predictions. What he said next was that the warming of the ocean around Antarctica will then lead to a disintegration of the West Antarctic ice sheet. And in the year 2014, on a Monday in May, 2 papers came out that supported a paper from a month earlier that all said that the West Antarctic ice sheet has now been destabilized in Amundsen Sea sector. That was a moment where I sat in my office and for half an hour just looked at the wall because it was hard to believe. That was the first tipping element of the climate system that we might actually be observing to tip. So what we did was we started our physical ice sheet model of Antarctica and looked at if what John Mercer predicted 40 years earlier actually would occur also if you hit it with a high-resolution numerical model. And it is indeed the case that if you destabilize West Antarctica at the Amundsen Sea sector, then it discharges all its ice into the ocean and elevates sea level by 3 to 5 meters. Which is exactly what John Mercer said in 40 years earlier, without satellite data and without computers. But West Antarctica isn't all. In East Antarctica, we have a similar situation, which hasn't been destabilized yet, but can be destabilized with further warming. So, already now we see a sea level rise because there's more water in the ocean, because the mountain glaciers are melting and because the ice sheets are melting. But also because the ocean water is expanding, it's salt water, and if it gets warmer, then it expands and sea level rises. So over the last 100 years, we have seen about 20 centimeters of sea level rise globally. And a higher sea level isn't necessarily a problem, but the rising sea level is a problem because we have built so much infrastructure near the coast. So many people live near the coast. We built our cultural heritage in cities like New Orleans, New York, Tokyo, and Hamburg, for that matter. So you see here a power plant, a nuclear power plant in Scotland, but sea level rise will become an issue in the decades to come and in the centuries to come indeed, because sea level will continue to rise because we have warmed the planet. And this warming is indeed being observed. We've seen about a degree, a bit more than a degree Celsius of global warming over the last 100 years. But this will continue if we don't stop to emit carbon dioxide into the atmosphere, which means that we have to stop burning oil, gas, and coal if we want to stabilize the temperature of the planet. And that is actually not disputable. We know this from basic physics, quantum mechanics. Max Planck is shown here, and thermodynamics tell you immediately that you will get about 3 degrees Celsius of global warming if you double the amount of CO2 in the atmosphere. So what we can do now is we can use computer models in order to see what kind of warming will we get if we continue to emit carbon dioxide as we've done so in the past and increasingly do currently and in the future, which is the red curve here, and which will end up at 4 to 5 degrees of global warming by the end of the century. Or if we keep the Paris Climate Agreement and stay below 2 degrees, which is the blue curve here, which would mean that we have to go to zero emissions by the mid of the century globally. Now, whether we do the one thing or the other, climate change will be the story of our times, the greatest story of our times, because it affects us globally. Coral reefs are dying globally already, and they have huge ecosystems in them, very rich ecosystems. And even if we keep the Paris Climate Agreement, we will probably warm the planet so much that coral reefs will die all over the world. What you can see here is the death curve of coral reefs globally, and you can see that at 2 degrees you have already met 100%. Because of the warming, permafrost is thawing in Siberia and Canada. It's destroying the infrastructure there, but it also emits additional carbon in the form of methane, that's CH4, and further increases the warming of the planet. The Arctic sea ice is melting dramatically. What you see here is the first satellite picture that we have from the region, 1979. Mid-September is always the smallest amount of ice in a year because of the end of this melting season. So here you can see the picture from 1979, and this was last year. We see a dramatic reduction in Arctic sea ice, and we will lose practically all of the Arctic sea ice even if we keep the Paris Climate Agreement. If we don't, we'll definitely lose everything in summer. So these are already the first signs of global warming, but the most threatening effect of this increase of the global mean temperature, and thereby the increase of the energy in the atmosphere and in the climate system, are the weather extremes. Now, weather extremes are much more complicated than a slow but constantly moving sea level rise and the shift of climatic regions and zones, because they are sudden and they are extreme. But we have reason to believe, and there are different reasons for different weather extremes, but we have reason to believe that weather extremes will intensify in the future. Now, it's quite simple that heat waves will intensify because we are increasing the temperature of the planet. So as you can see here, the probability for a warm event will increase. This is here for the summer in Europe, but that actually holds, this is observational data, but it holds also for other regions on the planet. And I believe that no climate scientist really should say that the Syrian crisis was caused by climate change. But what has to be said is that in the 3 years before the Syrian crisis, there were droughts, 3 consecutive droughts in the region. Now, another class of extreme events are tropical storms. We see them in North America, we see them in Asia, and they have very strong impact on society and the economy. Now, it's very difficult to predict tropical storms, hurricanes and typhoons. We don't know how often they occur, whether they will increase in number in the future. But what we know is that they draw their energy from the surface of the ocean. And we increase the temperature of the surface of the ocean. So we increase the energy that we provide to the tropical storms. So we have to assume that tropical storms will become more intense in the future under future warming. Now, even though Europe is not in the tropics and therefore technically they should be called tropical storms, but if we increase the temperature in the North Atlantic, we could even see kind of a hurricane season in Europe, because the hurricanes that didn't make landfall in the North American coast could make it all the way to Europe if we increase the temperature of the planet further. A huge class of weather extremes is related to the jet stream. The jet stream is a wind band that goes once around the planet in mid-latitude. So in the US, in Europe, and in Asia in mid-latitudes around 50 degrees north. And this jet stream is there because the Earth rotates, so it won't stop to be there, but its position is actually is stabilized by the temperature difference between the cold Arctic and the warm tropics. Now, under global warming, the Arctic is warming much more quickly than the rest of the planet because of the Arctic sea ice melt, but also because of latent heat transport, which is a bit more complicated. And that seems to destabilize the jet stream. Now, if the jet stream destabilizes, that means drastic changes in weather, namely weather extremes. We've seen this in the past. For example, Hurricane Sandy really just destroyed New York because it made a sudden left turn. And that was because the jet stream had meandered southward and we had a heat wave over Greenland, while at the same time the winds had changed and changed the path of Hurricane Sandy. But the jet stream really has caused problems in the past. In the last 2 winters, the United States in the north, from Chicago to New York, has seen dramatic snowfall events. In December 2017, there was a strong snowfall event which really stopped all life and also the economic life between Chicago and New York. That was a meandering of the jet stream, as you can see. And while the west of the west of the U.S. was very warm, the east was suddenly very cold. And if you enter cold air into a warm atmosphere, then you get a lot of snow because the water in the atmosphere, in a warm atmosphere, really becomes snow. A month later, something happened that really no one was aware of, because it happened in Siberia and very few people lived there. But it was dramatic anyhow, because over a period of 5 days, the temperature rose by 55 degrees Celsius, which is about 100 degrees Fahrenheit. Now, if that had happened in Moscow, we would have filled hospitals, because it is very hard for the human body. And a month after that was again the meandering of the jet stream. And a month after that, Berlin was 10 degrees colder than the North Pole. The North Pole hadn't seen any sunlight for 3 months and should be incredibly cold, but it was actually at the melting point because a piece of the jet stream had actually built an eddy and had carried warm air to the North Pole. I'm telling you this because in order to show you that there can actually be a fireworks of weather extremes, one after the other, and we have to expect in the future that these become more frequent and become more intense. We have other examples in the past. In 2010, we had a heat wave over Russia, while at the same time we had
extreme rainfall in Pakistan, which led to more than 10 million refugees and the biggest temporary freshwater lake on the planet. I can give you a number of events of that magnitude. And the economic damages are already today significant due to meteorological events. But what's more important is whether we will find this an intensification, and what happens if we don't have enough time between events to clean up the mess, if we don't have enough time to recover. If we have unabated climate change, which is leading to 5 degrees of global warming by the end of the century and won't stop unless we stop emitting carbon dioxide, then we will find an intensification of weather extremes, and we will find economic repercussions all around the globe, because if you hit, for example, Thailand by a flood, as happened in 2012, then you feel it in the hard drive market in the US and in Europe, as we've seen happening. Now, if these events happen more quickly and more strongly, we'll feel it stronger, and the question is, where is our limit of adaptation? So no matter whether we really meet the challenge and keep the Paris Climate Agreement, which will change the way we do business all around the planet, or whether we don't do anything and find an intensification of weather extremes, climate change will be, and already is, the greatest story of our times. Thank you very much.